Hi students, this is Mrs. Bettis here with an action-packed and fun-filled video on completing the square. Alright, why are we learning completing the square, you asked? Well, I'm glad you asked, let me tell you. First of all, graphing is not always available and it's not always reliable if our graph is not something that's nice. Okay, so solving by graphing is not practical all the time. Factoring is not possible all the time because you can't factor every polynomial. And lastly, to use square roots, we need to have the form x squared equals k, and that is not always obtainable. So we need another way. Well, how, you ask? Well, the premise behind solving by completing the square uses one thing that we learned from Algebra 1, and that's this notion that if we square a binomial, okay, so if we take a binomial and we square it, what we end up with is what's called a perfect square trinomial, and that's a squared plus 2 times ab plus b squared. So knowing that perfect square trinomials come from binomial squareds gives us what we need to be able to use completing the square. Okay, so there's our opening, and let's get into how to use this method. Okay, so before we get into the mechanics of how this works, I wanted to give you a visual, and this understanding is going to be paramount to your understanding of how to use completing the square to solve a quadratic equation. Well, first of all, if we were to use algebra tiles to model a polynomial, so this is x squared plus 6x. Physically, as a model, it has one x squared block, and it has 6 of these 1x blocks. Okay, so if you arrange them this way, it just makes some kind of weird shape. But what you see is that there's this empty space. So let's understand what completing the square means physically. If I had a model of a polynomial here for you, x squared plus 6x, it would look something like this. If I wanted to make this model into a perfect square, I would need to fill in this space. So how many blocks would I need to fill in that space? Well, if you look at our second model here, you see that they've added in 9 blocks to fill in that space. Now our model is a perfect square. So that is the work that we have to do when we are completing the square. We need to figure out how many blocks need to be added to our model in order to make our shape a perfect square. How will we do this, you ask? Well, mathematically, if we want to create a perfect square trinomial from an expression x squared plus bx, we have to follow this mathematical formula. We will take whatever that b value is, we'll divide it by 2, and then we will square it. And in doing that, we create for ourselves this perfect square trinomial. The beauty behind that is we can factor a perfect square trinomial into a binomial squared, and that is going to be our objective in solving or in completing the square. Here's an example worked out for you. Like what we had on our last slide model was x squared plus 6x. We took half of 6, and that gives us a 3, and when we square 3, we end up with a 9. And 9 helps us to complete the square. After we have our perfect square trinomial, we can then factor it into a binomial squared. Here is just the general algebra for you, and this is the model that we will follow when we solve these problems. Let's get into some examples. Example 1 says, complete the square to form a perfect square trinomial. And we'll take it a step further and we'll factor it too. So n factor. Alright, so our first problem is x squared plus 12x plus something. So we need to figure out what this value needs to be in order to fill the space. So if we think physically for a quick moment, we have one x squared block, and then on this side we would have how many x's, and how many x's would be on this side. So we have 12 total, and we have to split them in 2. So there would be 6 on this side, and there would be 6 on that side. So then what would we need in this space? So mathematically, we calculate that by taking 12 dividing it by 2, and then we have to square it. Because if you think about it, 6 times 6 equals 36. Mathematically, what we're adding to problem A is a value of 36. That completes our square. Our last step is to go ahead and factor it into a binomial squared. Our variable is x, and the square root of 36, like we have already determined here, is going to be 6. For problem B, we have x squared minus 5x plus some value, and they're asking us to complete the square. Well, using our formula, we're going to take our b value, which is -5, and we will divide it by 2, and then we have to square it. This time, our b value is not even, so we'll end up with a fraction. But that's not a problem because we're not afraid of fractions, right? No, we're not. -5 squared is just 25, and 2 squared is just 4. So to complete our square for problem B, we would have to add a value of 25 over 4. How does that factor? I'm so glad you asked. Well, it's just x, and then this would be the square root of 25 over 4 is 5/2. Just that simple. Let's keep going. On this slide, it is explaining the algorithm or the procedures, if you will, for how to solve a quadratic equation using the completing the square method. So the first thing we need to do is we need to move any constant term in our polynomial over to the right side of the equation. We need that x squared plus bx type of format. Once we have that format, then we can complete the square, making our polynomial into a perfect square trinomial, which is what we want. So here again is that formula. We're going to take half of b and we're going to square it. Once we've done that, we will physically complete the square by adding whatever that value was to both sides of the equation. It's important. You have to maintain balance. So you can't just add it on the left, but you have to add it to both sides of the equation. After you've done that, you're going to go ahead and factor into your binomial squared. All right. And after that, we are set up perfectly to solve this equation using square roots. Remember, square roots had to be solved using this format. X squared is equal to k. Well, our binomial squared is an expression squared, so it works. We're going to solve now using square roots. Our last step says that after you solve with square roots, by taking the square root of both sides, you're going to end up with 2 equations. And you just have to solve both of those equations, and you are all set. So this makes a lot more sense once you see it in practice. So let's get to some examples. So here's our first example. Our equation is x squared plus 16x equals -15. So the first step is to write it in x squared plus bx equals c format, and that is already achieved with what we have. So the next step is to complete the square. So we need to find half of b and we need to square it. So in this case, our b value is 16. So then 16 divided by 2 squared gives us, this is 8, and 8 squared is 64. So we are going to complete the square by adding 64 to both sides of this equation. So what we have now is x squared plus 16x plus 64. And then we have -15 plus 64. Okay? So now we're going to go ahead and simplify. I'm going to change my color because that contrast is kind of strong. All right. So on the left side, we know that this is a perfect square trinomial because we made it into a perfect square. So now we can go ahead and factor that side. So this is going to be x plus 8 binomial squared. And on the right side, -15 plus 64 leaves us with 49. Now, so we've completed the square. We need to factor and simplify. We just did that. Now we need to take the square root of both sides. So then I'm going to take the square root of this entire side, and I'm going to take the square root of the right side as well. So the square root of x plus 8 binomial squared just leaves me with the binomial by itself. So x plus 8 is now free underneath the radical. And the square root of 49 is plus and minus 7. So we've done this next step. Our last step is to write and solve the two equations that are presented here. So this is x plus 8 is equal to positive 7. And we also have x plus 8 is equal to negative 7. There's where the two equations come from. So now, finishing up, we subtract 8 on both sides, and we have one solution that x is negative 1. Our second solution, found by solving our second equation, is x is equal to negative 15. All right, there they are. Negative 15 and negative 1 are my solutions to this equation. How satisfying was that? I don't know about you, but that just made me happy getting to the solution for that problem. Okay, so here we go. We've removed all of the steps, but let's see if we can't do this from beginning to end. Now, if you're feeling a little special, you can go ahead and pause the video, try this yourself, and then play it and see if you end up with the same thing that we do. All right, so here we go. First step. I need to get this 6 out of the way so that I can complete the square into something that I know will work. So first thing, I'm going to add 6 on both sides. And so now my equation is x squared minus 4x is equal to 6. And I left space because I need to complete my square. So doing that, negative 4, I need to divide that by 2. And then I need to square that value. So that would be a negative 2, and a negative 2 squared is just a 4. So to complete the square here, I'm going to add 4 on both sides. Okay. So my left side is now a perfect square trinomial, and I'm going to factor that. So this is x minus 2. And the right side, I'm going to simplify. 6 plus 4 is 10. All right, let's keep going. Our next step, now that we have this in the format of x squared equal k, we're going to take the square root of both sides. So square root on the left and square root on the right gives me x minus 2, now free from under the radical. And on the right side, I have plus and minus the square root of 10. Because 10 does not contain any perfect square factors, I am going to leave it as the square root of 10. This is what you call an exact answer. Okay, so no decimals necessary, no calculators involved, just leave it as the square root of 10. Okay. We need to now separate this into our two equations and solve from there. So x minus 2 is equal to the positive square root of 10. And my second equation is x minus 2 is equal to the negative square root of 10. Add 2 on both sides. And we have that x is equal to 2 plus the square root of 10. And over here, lastly, add 2 on both sides. And we have that x is equal to 2 minus the square root of 10. So these are our answers. And these answers are what you would call exact solutions. Example walks us through what to do if we have an equation that has a leading coefficient of something other than a 1. We have something in the front here of other than 1. What we need to do first is to divide through by whatever that leading coefficient is so that we can achieve a 1 as our leading coefficient. We're going to essentially factor this negative 3 out. So what we have left over when we divide by negative 3 is x squared minus 4x plus 5 is equal to 0. Now we can proceed as we've done normally. Let's move this 5 out of the way. Then we have x squared minus 4x is equal to negative 5. Then we need to complete our square. So we have negative 4, hey, we've done this one, divided by 2 squared, and that gives us a value of 4 to add on both sides of this equation. Now that we've completed the square, we will factor and simplify. On the left, we have x minus 2. On the right, we have negative 1. So now that we have it in x squared equals k format, we will use square roots to solve. Take the square root of the left, take the square root of the right, and I have x minus 2 is equal to, well, remember this. The square root of negative 1 is our imaginary number, I. So then this becomes plus and minus I. All right, we have to separate this into two equations and solve. X minus 2 is equal to positive I, and x minus 2 is equal to negative I. Adding 2 for both equations, we have a solution that x is equal to 2 plus I, and adding 2 again gives us that x is equal to 2 minus I. So our solutions are 2 plus and minus I. You can write them together or you can write them separately. And there you have it. You can also write them as a solution set. And I think in your Delta Math, you've come across that solution set as well. All right. I told you it was going to be big fun. I hope you enjoyed it. I hope it was informative. And now it's time to practice. Let me know if you have any questions or confusions. I'd be happy to help. Thanks.